Hello students, in this video I would like to discuss problems on location of roots. Let us start. Total we have 6 cases. For each case I am going to discuss one of the problem. In my previous video I have discussed complete concept about location of roots. In this video I want to discuss only problems on location of roots. Total we have 6 cases. The first case problem depends on the first case. See, let x square minus m minus 3 into x plus m equals 0 quadratic equation. Be a quadratic equation. Find the values of m for which both the roots are smaller than 2. Two roots are smaller than 2. What about m? So we should find interval of m. For the roots are smaller than 2. 2 is any real number. First take given expression I am taking f of x. f of x equals to f of x equals to x square minus m minus 3 into x plus m. This is given quadratic expression. Here coefficient of x square is how much? Coefficient of x square is a, that is equals to 1, is positive. When quadratic expression leading coefficient is positive, then the parabola is always open upward. That's why you are drawing these two parabolas open upward direction. And also two roots are there. That's why it meets the quadratic expression at two distinct points, alpha, beta, x-axis. This is roots are coincide, alpha, beta equal. This is x-axis. Both the roots are smaller than 2. Where is 2? Here I am taking 2 is in this side, right side of alpha, beta, because both the roots are smaller than 2. Here also same. This is 2. Now what about f of 2? When the line, this is the vertical line if you draw, this meets parabola at here, this is the point 2 comma f of 2. F of 2 lie above x-axis. This is above x-axis, that's why f of 2 is positive. Similarly here also, this is the point 2 comma f of 2 which is positive. So first condition I am writing here, a is positive, clear, f of 2 is also positive. That's why a into f of 2 is greater than 0. This is first condition. That implies here a is 1. That's why f of 2 is greater than 0. Next, this condition is not enough to identify exact location of roots. Therefore, we are involving another condition, that is minus b by 2a. What is this? This is x coordinate of vertex minus b by 2a. Clearly 2 is less than, minus b by 2a is less than 2. That is condition number 2. Minus b by 2a less than 2. That is condition number 2. And next, here what about roots? Roots are here. Two distinct roots in this case. Here roots are equal. That means discriminant. This is the third condition. Discriminant of the roots here greater than or equal to 0. Why? Distinct roots. Okay. Discriminant is equal here. That's why discriminant is greater than or equal to 0. Using these three conditions, we can find out set of values of m. So f of 2 is greater than 0 means what is f of 2? Substitute here x plus 2. So that means 4 minus m minus 3 into 2 plus m greater than 0. Simplify this. That implies 4 minus 2m plus 6 plus m greater than 0. 10 minus m is greater than 0. So next, when we are multiplying with minus, this will be m minus 10 is less than 0. m minus 10 is less than 0. That implies m less than 10. This implies m belongs to minus infinity to 10, open interval. There is no equality. This is equation 1. Next, second case here. What about second case? Minus b by 2a, second condition. Minus 2 by b by 2a is less than 2. Minus b means here coefficient of x. Minus m minus 3, this is b. Coefficient of x by 2a. 2 into 1 is less than 2. That implies, so here m minus 3 by 2 is less than 2. That implies m minus 3 is less than 4, implies m is less than 7. That implies m belongs to, again same, minus infinity to 7, open interval. This is condition number 2. From condition number 2 I am getting this set. Next, use third one. What about third condition? Discriminant is greater than or equal to 0. Discriminant means b square minus 4ac is greater than or equal to 0. Here b is minus of m minus 3. So minus whole square plus m minus 3 whole square minus 4, a is 1, c is m greater than or equal to 0. That implies m minus 3 whole square minus 4m greater than or equal to 0. Expand this, m square plus 9 minus 6m plus 4m greater than or equal to 0. This is minus 4m. Sorry, minus 4m this is. So that implies m square minus 10m. This will be minus 10m plus 9 greater than or equal to 0. By factorizing, this will be m minus 1 into m minus 9 greater than or equal to 0. This will be m belongs to minus infinity to 1 union 9 to infinity. This is number 3. From 1 to 3, using these 3, we can find out the intersection of these 3 conditions will be the exact values of m. So therefore, we have to find intersection of these 3. First m, here numbers are 7, 10, 1, 9. Take numerical line. I am taking numerical line here. Even numbers are 1 is there, 1 is included, that dot. Next 7 is open because 7 there is no equality for this. Next 9 included, so dot. Next 10 not included, there is no equality. Minus infinity plus infinity. Now according to first condition, m belongs to minus infinity to 10. This is according to first condition. Next, according to second one, m is, see, second condition, m belongs to minus infinity to 7. Minus infinity to 7 means this part. This is minus infinity to 7. Next, for third, what about third? Minus infinity to 1, union 9 to infinity. So therefore, this is the exact our minus infinity to 1, union 9 to plus infinity. Where are the 3 lines? 3 lines are there here, this part. Therefore, that will be the intersection part. This part is required part. 3 lines are there. This part is intersection. Therefore, answer is n belongs to minus infinity to 1. 1 is included. That's why you should take close interval. This is the required values of m. The next question is, x square minus m minus 3 into x plus m equals 0 be a quadratic equation. Find the values of m for which both the roots are greater than 2. See, f of x equals to x square minus m minus 3 into x plus m. Same question, but here roots are greater than 2. X square coefficient is 1 here. A is 1 greater than 0. So what about b? B is coefficient of x minus of m minus 3. C is m. Here coefficient of x square positive means open upward direction diagram. I am taking here these are the roots alpha beta which meets x-axis at two distinct points. 2 I am taking in this side because our roots are both the roots are greater than 2, that's why 2 exactly left side of alpha beta. This is f of 2. The line meets x-axis, meets parabola above x-axis, that means f of 2 is positive. Here a also positive. So a greater than 0, f of 2 is greater than 0. In this case, roots are coincident. Here also that our two roots alpha beta greater than 2. This is f of 2, f of 2 is positive, this part is f of 2, above x-axis positive, therefore a is greater than 0, f of 2 is positive. The first condition. First condition is a into f of 2 greater than 0. Next condition number 2. So take minus here where is exactly 2 is left hand side of coefficient here. This is called what? X coordinate of vertex minus b by 2a. This 2 is exactly left side of minus b by 2a in the both the cases. This is minus b by 2a. That's why we are including nature of the roots is here. Discriminant is greater than or equal 0. So a into f of 2, a is 1, that means f of 2 is greater than 0. Already according to the previous question, f of 2 have solved already this value. I am getting after solving this m belongs to minus infinity to 10. Second condition is minus b by 2a is greater than 2. That implies minus of minus plus m minus 3 by 2a to a is 1 greater than 2. So m minus 3 is greater than 4. M is greater than 7. That implies m belongs to 7 to infinity, condition 1, condition 2. Now solve discriminant is greater than or equal to 0. Third, discriminant is greater than or equal to 0. Discriminant formula by solving this b square minus 4ac greater than or equal to 0. B is minus of m minus 3. So minus 1 square plus 4. A is 1. C is m greater than or equal to 0. After simplifying this, we will get minus infinity to 1. Minus infinity to 1 union minus infinity to 1 union 9 to plus infinity. This is condition number 3. Now draw numerical line, find out intersection of these three conditions. Okay, so therefore here this is what is this? The value 1 is included, take dot. Next 9 also included, dot. 10 not included, I am taking like whole. Next 7 also there, not included. And now write the range according to our first condition. M belongs to minus infinity to 10. So here range is according to first minus infinity to 10 means in this side. This is minus infinity plus infinity. Next, according to second condition. Second condition is m belongs to 7 to infinity. So this is 7 to infinity. plus infinity. Next, and the third one we have to draw a range of third minus infinity to 1, minus infinity to 1, or 9 to plus infinity. So, what about the range? The intersection of these three lines, observe this, three different colors. That will be intersection of, this is the intersection, this part only, these three lines. The intersection is 9 to 10. Therefore, our answer is n belongs to 9 comma 10. Here 9 side closed because it is included dot, but 10 side open. This is a required range. Okay. The next question is, let x square minus m minus 3 into x plus m equal 0 be a quadratic equation. Find the values of m for which one root is smaller than 2, other root is greater than 2. Same question, but condition is different here. Third case, problem number 3, alpha beta f of x given x square minus m minus 3 into x plus m. Here a equals to 1, positive, open upward direction, parabola we are drawing. One root is smaller than 2, other root is greater than 2 means I am taking 2 here in between alpha beta. Here alpha is less than 2, beta is greater than 2. That's why this is the possibility of the diagram. This is x-axis. See, f of 2 value is how much? This is f of 2, which graph line meets the graph below x-axis means f of 2 is negative. Below x-axis f of 2. That's why a into f of 2 is positive into negative, negative. That implies f of 2 is less than 0. Here we are not including this diagram. Why? This is not including because one root is greater than 2, other root is smaller than 2 means here in this case alpha beta coincide. But here one root is small, other root is greater than of 2. That's why we can't include this graph. Similarly, next, here clearly discriminant is greater than 0, that's why need not include that. Already this equation, this condition takes care of discriminant greater than 0 also. Why? Graph meets x-axis clearly. Less than, one root is less than 2, other root is greater than 2 means clearly graph meets x-axis. That means roots are distinct. Therefore, this condition is enough here. A into f of 2, a is positive, f of 2 is negative means graph compulsory meets x-axis. A positive, open upward. F of 2 negative. That means graph exactly meet x-axis. That's why already discriminant is greater than 0. That's why need not take this condition. One condition is enough for this question. F of 2 means 4 minus m minus 3 into 2 plus m is less than 0. That implies 4 minus 2m, next plus 6 plus m less than 0. 10 minus m less than 0. Now multiplying with minus m minus 10 greater than 0. That implies m is greater than 10. So m belongs to 10 to infinity is the range of m. These are the m values. Okay. The next question. Let x square minus m minus 3 into x plus m equals 0 be a quadratic equation. Find the values of m for which exactly one root lie in the interval 1, 2. Exactly one root lie in the interval 1 comma 2. Again here open upward direction because f of x equals to x square minus m minus 3 into x plus m. A is 1 greater than 0, open upward direction. Next, I am taking this is alpha beta, one root is lie in the interval 1 comma 2, exactly one root. That's why I am taking the graph like this 1, 2. Or otherwise you can take here 1 and here 2. One root is exactly one root is lie in the interval 1 comma 2. Indirectly roots are distinct. That's why need not draw this graph because here roots are coincident, but here roots are different. Why? One root is exactly one root lie between 1 comma 2 means the other root is outside the interval 1 comma 2. That's why roots are different. That's why one graph is enough here. Need not draw this graph. And also, what is f of 1? F of 1 is positive and f of 2 is negative. That means f of 1 above x-axis positive, f of 2 below x-axis negative. Therefore, the condition is here a is already positive, so 1. So the condition is f of 1 into f of 2 positive into negative here will be negative. F of 1 into f of 2 is less than 0. This is the condition. So what is f of 1? That implies f of 1 is 1 minus m minus 3 into 1 plus m into f of 2 4 minus m minus 3 into 2 plus m less than 0. That implies 1 minus m plus 3 plus m. Next, this is 4 minus 2m plus 6 plus m less than 0. Here mm gets cancelled 4 into. So this is finally is 10 minus m less than 0. Here clearly 4 is positive, that's why it should be negative. So 10 minus m is less than 0. M minus 10 is greater than 0. M greater than 10. That implies m belongs to open interval 10 to infinity. Here listen. Need not take discriminant also here. Why? One root is already f of 1 into f of 2 less than 0 means f of 1 is positive, f of 2 is negative means graph exactly meets x-axis at one point clear. It meets alpha. Why? F of 1 positive, f of 2 is negative means graph meets x-axis. That's why this equation is enough. Need not take discriminant is greater than 0 once again. Okay, that's why our range is m belongs to 10 comma infinity. Next question is let x square minus m minus 3 into x plus m equals 0 be a quadratic equation. Find the values of m for which both the roots lie in the interval 1 comma 2. Here both the roots lie in the interval 1 comma 2. These are the roots alpha beta. Here open upward again, coefficient of x square 1. So a is positive, open upward direction. So next, these are the values 1 and 2 I am taking here because both the roots 1 alpha beta lie in the interval 1 comma 2. That's why we are drawing this. Not only this, we can take another graph also. This also satisfies the same condition. Here 1, this is 2. Roots are coincide here. Alpha beta lie in the interval 1 comma 2. So this also included here graph. Okay, that means here roots are distinct. Alpha beta here roots are coincident means discriminant is greater than or equal to 0. That is one of the condition. And also here both the graphs minus b by 2a is lies between 1 and 2. Here also minus b by 2a lies between 1 and 2. That is second condition. Here first f of 1 is what? What about f of 1? F of 1 is positive, and here also f of 2 is positive. Both the cases. F of 1 positive a is greater than 0. This is f of 1 positive, f of 2 positive. F of 1 positive, f of 2 also positive. So the condition 1 is a into condition 1 a into f of 1 is greater than 0, comma a into f of 2 is greater than 0. Here we may force to write this condition also. If you write like this, f of 1 into f of 2 is greater than 0 in both the cases. Here also positive. A is positive, 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 positive. But we can't write this condition because if you take the roots in this model, also for example here 1, this is 2. Now alpha beta. So 1 comma 2 lie in the alpha comma beta. In this case, f of 1 is negative, f of 2 is negative. But what about f of 1 into f of 2? F of 1 into f of 2 is greater than 0. That means if you write this condition, we will get this condition also, this case also. So that's why we cannot write this equation f of 1 into f of 2 greater than 0. We can't write this expression. That's why we are taking separately a into f of 1 greater than 0, a into f of 2 is greater than 0. Need not take this part. Here minus b by 2a, x coordinates of the vertex always lie between 1 and 2. So the second condition you can write like this. 1 less than minus b by 2a less than 2a. Two cases is satisfied here. This is minus b by 2a. 1 less than minus b by 2a less than 2. And also, what about the roots here? Roots are here distinct, here roots are coincident. That means third condition is discriminant is greater than or equal to 0. In this question, you have to take three conditions. So that implies first m minus 3 into 1 plus m greater than 0. That implies 4 is greater than 0. So clear 4 is greater than 0, no use of this. Next a into f of 2 is greater than 0. That implies f of 2 is greater than 0. This implies we are getting, according to previous questions, m belongs to minus infinity to 10 when you take f of 2 is greater than 0. This is number 1. Next, second condition, minus b by 2a, 1 less than minus b by 2a minus m minus b by 2a minus m minus 3 by 2a, a is 1 less than 2. That implies 1 less than m minus 3 by 2 less than 2. 2 less than m minus 3 multiplying with 2, 4. That implies adding 3 on both sides. So 5 less than m less than 7. Next one, m belongs to 5 to 7, open interval. This is condition number 2. Next, condition number 3, discriminant is again greater than or equal to 0. M minus 3 whole square, 4a is 1c, m greater than or equal to 0. That implies we'll get m minus 1 into m minus 9 greater than or equal to 0. That implies m belongs to minus infinity to 1 union 9 to plus infinity. This is number 3. Now draw numerical line. Take all the values. 1 is included here. 1 is included. Next 9 also included. 10 open. Next for 5 and 7 also open interval. So according to first condition, m belongs to minus infinity to 10. Next, according to second condition, m belongs to 5 to 7. Now according to third one, m is minus infinity to 1, minus infinity to 1 and 9 to plus infinity. See, there is no clearly there is no intersection of all these three lines, blue, red, white. There is no intersection. Therefore, answer is n belongs to null set. The next problem is let x square minus m into m minus 3 into x plus m equal to 0 be a quadratic equation. Find the values of m for which one root is greater than 2, other root is smaller than 1. Clearly, roots are different here according to data. Same f of x is x square minus m minus 3 into x plus m. A is one positive open upward direction. So these are the roots alpha, beta. Different roots you have to take because one root is greater than 2, other root is smaller than 1 means. Roots, the given numbers 1 and 2 here. This is 1, I am taking 2 here. Because one root is clearly, one root is greater than 2. See, beta is greater than 2. One root is smaller than 1. Alpha is smaller than 1. That's why this is possible diagram. Here, clearly roots are distinct. Why? One root is less than 1, other root is greater than 2 means roots are distinct. That's why this graph is enough. Now what about f of 1? Here, this line meets the graph in the below x-axis means the f of 1 value is negative below x-axis. Similarly, f of 2 is also negative. Therefore, the conditions are a into f of 1 negative because a is positive, f of 1 is negative. Similarly, a into f of 2 also positive into negative, negative. This is the condition 1. One condition is enough. Here need not take discriminant greater than 0 case because when a is positive, a into f of 1 is negative means 1 is these two are opposite signs means graph exactly meets x-axis. Therefore, the roots are distinct. That's why this condition gives roots are distinct. That's why need not take discriminant greater than 0 once again. Okay, so a is 1, f of 1 is less than 0. By substituting x plus 1, 1 minus m minus 3 into 1 plus m less than 0. This implies plus m minus m gets cancelled. 4 less than 0. 4 less than 0 is impossible. Therefore, we have to leave this here only. So there is no such values of m satisfying this. This is contradiction statement. That's why no such values of m satisfying the given condition. Therefore, answer is n belongs to 5 is the answer. Need not to simplify this also. Why? 4 is less than 0 is not possible. That's why this is enough here.